Okay, now today we want to go through the very last section for chapter 1, so the 1.10. Now 1.10 in the beginning, we want to talk about some idea from statistics. So most of you, I assume you already took a statistic before this class. Now, statistics, usually we don't talk about something very 100% precisely, just approximate your answer. Approximate. Okay. Now, on the real life, for example, if you run a company, and if we talk about your revenue, okay. So sometimes in the beginning you don't have much revenue, and in the end your revenue grow and probably a little slow down, a little sometimes up, sometimes go down. That's possible, right? Up and down, up and down. Okay. Now, if you want to try to use a math equation or math function to approach this one, so it will look like this. This part looks like a parabola, but up to here is a little bit different, right? And keep going, you change the graph, and here you change it to another graph, and here maybe you feel like oh, it's a parabola again. Now it's just the approximate the real data. You approximate the real data by some model, some mathematical model. Okay. And sometimes your data not really follow some math model. Sometimes your data this way. Change color. Your data here and there and there, right? Not exactly follow the model. You don't guarantee that because real life is unpredictable and not precisely. So your model may be a little bit off. Your real data may be a little bit off the model. So there are some different methods that we want to approach. So what type of method we want to approach? We talk about two different techniques to fit the models. But actually we have more than two different ways. We have more. But here we only talk about two types. Number one, direct variation. Number two, inverse variation. So today we only talk about two simple easy one. And you use the mathematical model to approach the real life data. We try to find this model very, very close to the real situation. So we have number one, direct variation. Number two, inverse variation. Oh, and the actual number three, we have this square regression line. And what's this? We don't talk about this one on this section. Okay, you may learn this from statistics. So what we want to learn for today is number one and the number two, direct variation and the inverse variation. Now let me erase those marks right now, and I would like to give you some more examples here. Okay. So if we try to model our data by a mathematical equation looks like this, for example, but our real data is somewhere just sometimes close, not really 100% close, sometimes a little bit off. Okay, so your model, we will say pretty close, but not 100%. And how we decide that this is a good model or not. That's one way. We use the sum of the square difference. What's the sum of the square difference? We try to find the difference between the real data and the modeled data. Okay, there's some difference. Like here, no difference, right? Difference 0. And the difference, for example, this difference sometimes is positive, sometimes negative. So depends on, oh, okay. For example, like that. Now you can see that the real data and the model, they have a big some difference. The difference sometimes is negative, sometimes is positive. Negative, positive. But no matter it's negative or positive, they are still the difference. So if you have plus all the difference together, they may be cancel out. So we don't want the difference being cancelled out. So that's why we try to use the square. Okay, you square it, then it becomes positive. Square, you square all the difference. When you square all the difference and then plus them all together, then you can see how big is the difference. Now, I don't want to spend too much time to talk about this because statistic may teach you more detail. Here, you have to learn is just the name. Sum of the squared difference can tell you the model you choose is a good fit or not. If the sum of the square difference too big number, then we may want to give up this model and choose another one to see anything can make a, a smaller difference. If you can have smaller difference, right, more close to the data is better. Okay, so that's the idea for number 2. Number 3. Number 3 is something I cannot explain here for the detailed concept right now, but I can only tell you after you set up the model and compare with the real life data, we have another way to measure if this model is a good model to fit the data or not. This another way to do it is we create a number called R value. And what's R value? You need to learn statistics to understand. Okay, so here it's too much work for me to explain. So we just say there's something called R value. This R value, another name is correlation coefficient. So this R, this means R, same thing. Okay. Now, if this R is close to 1, the absolute value of the R, and how we calculate this R, don't worry about that. If you want to really understand that, you need to take a statistic. Okay, so when R very close to 1, that means the model is good. Or we say the more of the closer of R approach 1, the better model. Okay. When the correlation coefficient is very, very close to 1, absolute value, then we say this model is very good. If the R value, absolute value is almost 0, means this model is not a good fit to the data. Now, again, I will say, here all you have to learn is just go through the name. So I'm going to erase all my mark here and let you understand. You don't need to worry about, oh, I don't understand these 3 formulas or detail. You don't need to worry about that, because there's a lot of things to learn from statistics. And all you have to learn right now is you understand we have some method to choose a good model to fit our real life data. And we don't learn it right now. We just learn the name. Understand? Okay. So first, you have to remember that the R value name is correlation coefficient for you to decide this is a good fit to a model, yes or no. And the number 2, we can use the sum of the squared difference to find a model that you can choose. Same thing, these 2 are similar. Okay, you use either this method or you use this method to decide if this model is a good fit or not, is a good approximate or not. Okay, and number 1, this the square regression line is similar to this idea, squared. And the same thing, we don't work on this part for today. And for today's class, we want to pay attention on direct variation and the inverse variation. So you understand among so many different methods, mostly we use direct variation and the inverse variation, but we may choose some other model that's possible. But today we only talk about these 2 models. Now, direct variation, inverse variation, what's that? So right now I want to tell you, actually you're supposed to learn this from Algebra 2. Now, direct variation. Direct variation is x and y, they equal to each other by multiply a constant number. For example, y equals to 1/3 times x. So by this way, for example, when x is 1, when x is 1, y will be 1/3, right? When x times 2, y times 2. When x times 3, y times 3. Yes? Okay. So when x grows, y grows. And when you make x is 1/2, y will be times 1/2. Okay. So 1/2 times 1/3. And when x divided by 3, y will be divided by 3. They always follow the same trend. Or we say x, y are proportional to each other. And the other one we mostly use is called inverse variation. Inverse variation, this time x is on the denominator and with a constant number k. For example, y equals to 1/3 and the x in the denominator. So compares to direct variation, when x is 1, y is 1/3. But when x double, y need to be divided by 2. When x triple, because x is in the denominator, therefore y become 1/3. Okay? So then we call it inverse variation because when x grows and the y kind of becomes smaller, right? When x times 2, it becomes divided by 2. That's the different way. And the direct variation, when x times 2, y times 2. When x times 3, y times 3. So we call this direct variation. So this is the name of the variation we want to work on for today. And not only these two, sometimes we call it a joint variation. Joint variation means we have more than x and y. We have x and y and z and more. So we join more than two variables together, and it's always direct variation. Joint means direct variation. This is the new vocabulary word you have to memorize. We also mentioned this joint variation from algebra 2. Now, if you have some variation combine the direct and the inverse together, then we call it combined variation. Always rewrite combined variation. Okay, so before we start doing the examples, first I introduce some vocabulary or definition for you. 1, 2, 3, 4. That's all you have to do. Okay, and keep going. We try to do the homework question. Okay, so right now there are some data here. How many data? 1, 2, 3, 4, 5, 6, 7, 8, 9 data here. Depends on the year. So you have 9 data. And you need to graph those data on the coordinate system. And that's not too hard. And which one is the right one? So if you only talk about the data, looks like this is the only one. Okay? Looks like it's the only one. And also, so first plot the actual data. That's not too hard. You just put all the xy in the coordinate system. And the model on the same graph. What's the model here? This is the model. They already provide everything for you. And what's this model? Y equals to mx plus b. M equals to 1.92. B equals to 65.0. So this is a straight line. The straight line because slope is positive. When you have positive slope, the line need to go this direction. That's right. And this is negative slope. That's not the right one. This is negative slope, not the right one. And for the positive slope, only these two. Now, you may just find some point to graph this line. You can choose x, y, and choose any coordinate from here. Okay, you plug in, choose 2 points and connect. Then you're supposed to have this line. So this is the model, and this is the data. Now, do you think this model is pretty good? I think so. This is pretty good model. Number 5. I would like you to pay attention to read. Assume that y is direct proportional. So this other way is say y is direct variation as x. And the direct variation means they have direct proportional to x. So this is the model times. When we talk about direct variation, we use time. And when we talk about inverse variation, like next one, oh, not the next one. Where is the next one? Okay, not here. Okay, if you have an inverse variation, then this x will be on the denominator. So number 5, they didn't really give you the function or equation or formula, but they give you the name of the formula. If they give you the name of the formula, as soon as you understand this name means direct variation, then you memorize the formula. You can use it. So when you are using the direct variation formula, always first thing we solve for k. First you solve for k. After you solve for k, mostly they will ask you plug in k to the original equation and then complete. Write down the equation complete by you put the k inside. Okay. So first step, how you do this question? They give you the name of the formula, so you list the formula. That's step 1. And then plug in x and y they give to you, right? Plug into the equation. By this way, you can solve for k. After you solve for k, you put the k equals 3, then you are done. Pretty easy. Number 6. Number 6, they already tell you the model. So all you have to do is just follow the formula. But right now, furthermore, they talk about, they give you the k and they give you n. Okay, so you have the whole thing, whole formula here. Now, if you follow the formula, y equals to 1/4 x squared. Now, when x is 2, you calculate. When x is 4, you calculate. the y value. This is y. Just plug in, not too hard. And after you, let me erase those mark, ugly mark. So after you finish calculate the y value, then what do you have? You have data x, y, x, y, x, y, x, y, x, y. And then you just plot 5 points to the coordinate system. Then you are done, right? So here, all the points you plug in. Number 7, same thing, similar. Just this time, the formula looks like a inverse variation. And then you just try by yourself. Number 8. Number 8, they provide the data for you. So compare with the question from number 6. They give you equation and ask you to find the data. This time, they give data and ask you to find the equation. And again, I said in the whole world, there are so many different type of equations. Why we choose this one? Because they ask you to choose either this one or that one. So you have only 2 choices. Otherwise, you have more than 2 choices. Understand? You have more than 2 choices. But for this question, they only ask you to choose from number 1 or number 2. Then that's easier. So you can try. For example, you also try this one to see which one works. You plug in data. This is y, this is x, and try to find k, right? And remember, if choose one formula, you don't supposed to change k. Once you choose this formula, you need to find exactly 1. Exactly 1k. Okay, so you have only 1k for the function. Now, if you choose 3 and 7, then k equals to 7 over 3. Now, if you change it to 6, means you times 2, right? If you times 2 here, you need to times 2 here. Yes, even though you didn't try to find k. But if you understand the concept of the direct variation, you can see that when x times 2, y times 2. When x times 3, y times 3. When x times 4, y times 4. So if you follow the same trend, then it means direct variation. If that's direct variation, this will be the only one formula you need to choose, not this one. This is called inverse. And the direct need to be x on the numerator, both x and y in the numerator. So that's how you choose number 8. Number 9. Number 9, same thing, they give you data. And then this time you can see that when x times 2, y divided by 2, right? When x times 2, y divided by 2. When x times 3, y divided by 3. So times 2 divided by 2 times 3 divided by 3 times 4 divided by 4. In this case, it will be a inverse variation. Inverse variation, this is the formula you need to follow. And then you try to plug in to find k. Okay, so when x is 5, y need to be 48. So how you solve for k? You multiply 5 on both sides, then you can solve for k. Okay. Number 10. Use variation terminology to describe the formula. So this pretty much looks like y equals to k and something. Okay, so if we say the capital K, X, so y direct variation to capital X. But right now this capital X actually is x squared. So we say y direct variation to x squared. Or you say square of x. Number 11. Y is inversely proportional. So inverse variation when x on the denominator, y on the numerator. Okay. So you try to find k always. And then they give you when x is 3, y is 2. So you can times 3 to solve for k. After you solve for k, you plug in k here. This is 6. So k is 6. Then just rewrite your final answer. Then you are done. Okay. Number 12. Varies directly. So p varies directly as x. So directly means both p and x, they are both on the numerator. So varies directly means p and x, they are both on the numerator. And when p varies inversely as square of y squared. So p and y squared are inversely, means if p on the numerator, then y need to be on the denominator. Okay. Let me change the color for you. Okay. So I will say P varies two things, two types. One is direct, one is inversely. Let me erase. I would like to talk about some English grammar for you. So some students, you have had time to read the question correctly. So let me talk about the grammar. Okay. So here, what's the subject? This is the subject. And what's the verb? Varies. Okay. And the varies. Two things. Number one, directly. Number two, inversely. Okay. So P is the subject. And the varies. Number one, directly with x. Number two, inversely with y squared. Square of y means y squared. So that's how you set up the formula. So once you set up the formula, you need to find k. Okay? We don't know k in the beginning. Okay? You need to solve for k. Now they tell you when p equals to 28 over 3. That's when x is 28 and the y is 12. And remember, y need to be squared. So you solve for k. Number 13. Please read the question first by yourself. And the most important thing you have to pay attention is varies directly. Dense varies directly as the applied force. So L and the F are both on the numerator because varies directly. So basically you have to, first step, you read the question and you set up the formula. And then you plug in all the data. You can find all the data from if you read all the problem. So 25 pounds here, and this is length, right? So as long as you can tell, a distance means length, okay? And the weight, how many pounds, is the force. Probably if you never learn physics, probably you have hard time to understand. Let me tell you, okay? So we have dense. Dense means distance, okay? Yes. And the force, let me use other color. Force. The force, you put the force on the screen. A spring means weight. Okay. So this is how many pounds. And the length is the distance, or how many inch. So you need to plug in the data to the right position and then solve for k. So after you solve for k, then you have the after you solve for k, then what do you have? You need to solve for f when. So they ask you to find the force when the length is 5 inch. So first the question give you 25, 1.9, and then they ask you how about the length is 5. Let me change the position. So when length is 5, force is when length is 25, the weight is 1.9. And then after you find the k, you want to figure out when length is 5, what's the force? So you want to solve for the force, this F. Okay, so you need to read the question to fully understand the whole thing. And the very last one question. This question, a work W varies jointly. Remember earlier I said jointly means directly. Now why they don't say directly? When they say jointly, means there are more than x and y. So you have x, y, probably z. And right now here we have w, m, and h. So you don't have just the x, y. Okay, you have more than two variables. We say jointly. Jointly with m and h. So W jointly means directly with M and H. And you need to find K. Pretty easy, right? So if you understand the question, then it's something like too easy. I will say that, okay? And then they will tell you what's W, what's M, what's H. You need to find out from the second sentence. And then you solve for K. After you solve for K, then you have W equals to, well, this very ugly number, right? 21168 over 120 times 18 and times M and H. So this is the new formula. And it depends on what's the next part they give to you. They give you find the amount of work. So you need to find amount of work required to lift a 110 kilogram object, and you want to lift up for how high? 1.5 meters. So you follow this formula, and then you can solve for that. So I show my work here, and after you are done, you simply use calculator, or you want to hand calculator, do whatever you want. You reduce, and then use calculator, you can find the number, but basically you can directly try your own homework question. Then if you do it right, then you are fine. So I'm done with chapter 1, and pretty soon I'm going to make a video for 2.1. So see you next time. Bye bye.